In certain videos on the internet, you may have seen where they talk about making gravity cells and this and that. Put two pieces of metal in the electrolyte and you get a volt or so. Then you put it in current and you get 5, 10, 15 milliamps and whatever. Oh, goody. The question I have is, what the heck can you actually do with them? What productive work can you get done with gravity cells that you make at home? In this video, I'll shed some light on that. Normally, you want to match your load to your power supply, and considering that most gravity cells that people make first off in the starting is relatively small ones, then that means that load options you have are going to be relatively limited. Like these here, they put out about 1 volt a piece. Open circuit and shorted, they put out about 300 milliamps, or about 1/3 of an amp. And at full, the maximum useful load, they put out about 0.8 volts at around 100 to 125 milliamps. So, for 3 of them, you about replace 2 AA or AAA batteries. So for a set like that, you can power things that are normally supplied by 2 AA or AAA batteries, like these. Little AM/FM shortwave radio on a little AM/FM clock radio. A standard AM/FM radio. Any of those things can be quickly hooked up to those and ran for a considerable period of time. Based upon the design of these, with the plate that you've got on them, the zinc plate, these would run the devices previously mentioned about 10 to 16 days. The size of zinc plate I've got on these will produce a total usable life of around 5 amp hours. Considering the pre-stated devices pull around 10 to 15 to 20 milliamps, you're looking at a total life of probably 10 to 15 days. Continuous operation. That's with the radio playing continuously, and with gravity cells you normally want to operate them continuously, because if you leave a gravity cell unloaded, it tends to degrade, so to speak. So for that application, running radios for receiving emergency information, weather, news updates and stuff, pretty easy. Is another type of load that's nice for driving off of gravity cells, and that's LEDs. Require around 3 volts, constant current, and the gravity cells with a relatively high internal resistance act as a relatively good current source to drive an LED. Requirements: 3 volts at load normally indicates that you need about 4 gravity cells to drive it. Pulling them a bit below the normal 0.8 volts per cell, which operating a 3 volt LED at its normal voltage range, they'll be running around 0.75 volts apiece. Pretty much they're close to their ideal load voltage, so driving an LED is a definite useful thing for them. But remember, when driving an LED, that these units will put out around 100, 125, and at around 0.75 volts, about 150 milliamps. And if you try to drive a 30 milliamp LED with these here, you're going to crook it. You've got to have an LED that will handle the current, like this one. This is a Osram LED, Surface Mount LED. I mounted onto a copper wire for demonstration here. It's capable of handling 100 milliamp up to 200 milliamp drive, which is a good match for these gravity cells here. Hook it up. Let's see here. Positive to the positive. Negative. And negative. And you got a nice light that can run continuously based up on full load, probably about 40-50 hours of continuous light you can get from this set of gravity cells driving this LED. If you only want to use them at night, remember, gravity cells like constant load, so if you don't want to have the light burning all day long, then, get this straight here, don't want the light burning all day long, then you can take and hook the gravity cells to the radio during the day to get news, weather, and information. And when the night comes, hook up the light again. And I found with how much or how little this radio pulls, you can operate both at the same time at night without a problem. And operating just the light at night, you're going to drag out the lifetime of those cells before you have to change the zinc plate on the top, up to about 4 or 5 days of light all throughout the night. Full 12 hours of light a night. If you're only running 6 hours or so of light a night, you're talking 8+ days before you have to replace the zincs. The other application for those strange looking gravity cells, oddly enough, during an emergency situation where you don't have power, and running a generator to charge small batteries is extremely wasteful, is charging batteries. Strange it may sound, but two gravity cells make a nice charger for a normal NiCad battery. 3 cells, or best 4 cells, make a good charger for 2 NiCad batteries in series. And in general, with those size cells, you will be talking about 10 hours from the time you hook them up to the time these are fully charged. And in total, you're talking about 10 full recharges before the zincs are depleted. And you have to put in new zinc plates with the way those cells are constructed. If you had heavier zinc than I had for constructing these cells, then you would get a lot more recharges, a lot more light time, and a lot more radio time before you have to do anything to them. But considering that those are built out of stuff you get from normal hardware supply, the thickness of the zinc is what limits the lifetime of them. Well, not the entire cell, but the zinc plate on top will deteriorate and get disintegrated. Then you have to put another zinc plate on the top to keep it going. And the other thing you can do with those size cells is just about run an FRS transceiver. This one, if you had 6 of these cells, since this transceiver has 4 batteries in it, remember I said 3 cells is about equivalent two AAA batteries or two AA batteries. So two sets of two batteries means I'd have to have two sets of 3 cells. So to run this unit off these, I'd have to have 2 more cells made up. And this one, running relatively low voltage, pulls around 120 to 200 milliamps on transmit. So this FRS transceiver would just barely run off of cells this size if I had a set of 6 of them. Preferably, if you're going to be operating an FRS transceiver or any other type transceiver, you'd have larger gravity cells than that. Then it could easily accommodate the current that device like this would pull. And there's another option here. The other option kind of runs along the same lines as charging batteries. And it's especially applicable if you are not going to be using your device in question continuously, or if it's going to be a larger device that you're not going to be using it continuously, whatever, then well, actually, this one here will run off of 6 of those batteries without modification. But a larger device that pulls more current that you're not going to be running continuously will run off those cells, given one little condition. If you use those cells to charge rechargeable batteries in the device, and then whenever you're using the device runs off the rechargeable batteries, and then when you're got the device setting unused, then the batteries are recharging off the gravity cells, thus keeping a constant load on the cells all the time. You can do that on a device like this by putting the batteries in and making a little metal tab or hooking wires to the outer 2 battery connections and hooking those wires to your gravity battery. And when you do that, of course you have a pigtail to the gravity battery, but when you're using it or have it turned on, those are supplementing the power requirement. And when you have it turned off, those batteries will recharge the batteries it's in the device. And that means you can use a lot smaller gravity batteries than this to keep a transceiver or any other device running stuff. Of course, if you want to run the device without having to have rechargeable batteries as intermediaries, then you got to build larger gravity batteries. But if you're going to use a rechargeable battery as a storage device for the energy coming from the gravity batteries, then it allows you to get away with a lot smaller gravity batteries and a lot larger or more power hungry device that you're running. And of course, you can redesign your battery, your gravity battery, to better suit low current, continuous charging by changing the shape of it. I'll get into this when I talk about constructing the batteries you see here in the next video. But a taller battery, smaller diameter, generates less continuous current with a higher internal resistance. But the time this battery here will operate at that lower current is a lot longer. Talking month, 2 months, 3 months that this battery could run without doing a dang thing to it. While these here, you're looking closer to 10, 15, 20 days maximum at lower current. So for battery charging, a gravity cell designed for low current is better. And you can take, as I said, if your use is infrequent, then a relatively small set of cells can power a relatively large device, like a boombox or something, even if you wanted to. But if you try to run a boombox on those cells you see there, you wouldn't have very much luck. If you want to operate this radio, you can do it all day long for literally months. No, not months. Weeks on end without much issue. Now, if you wanted to operate a lot bigger equipment like CB radios without the help of rechargeable batteries, NiCads as intermediaries, then you gotta start thinking a lot bigger containers to build your gravity batteries out of. And unless you want to go with those, then you can still operate, get it right side up, CB radios with one little condition that, like on a CB radio, take 12 volts, have 12, 13, or 14 cells like that lined up, and use it to charge rechargeable batteries, probably bigger than this. Then you could probably use, ideally, something like this, probably 3-4 hours a day, running off of those. Albeit, if you're going to use one of these, probably be more efficient to use lithium polymer batteries. Proper amount to get 12 volts to run one of these, and use the gravity cells to recharge it. Again, running 4-5 hours a day. This unit here, you'd probably get 10 days of usage out of those cells before you have to put in new zinc. Or you could use standard lithium ion cells. But keep in mind to have the batteries such and such a voltage that the lithium cells will not go above 4.2 or 4.1 volts per cell. Otherwise, things could get very nasty. And the final thing you can do with them is use them to charge USB devices like cameras or cell phones. Question: how in the heck do you do that? Well, get 5 of them, sufficiently large size, bigger than those, probably not quite as big as this, and take and hook it up to a USB cable with the proper pins shorted. Then your USB device will recognize it as a charging source. When they're unloaded, they will produce about straight 5 volts. And when they're fully loaded, they're going to produce about 4.5 volts, which is pretty close to the USB specification. That's for half amp. And as I said, probably not this size, but larger than those. 5 of them. Then you can charge your USB devices off of the things if you have no other source of power. And in the next video, I'll show you how to make those things, these things, and stuff from relatively simple stuff you can get around the house, plus a couple key components from the hardware store. One is zinc flashing, which is normally sold for mold or moss control on roofs, and copper sulphate, which is normally sold in the plumbing section to get rid of roots from your septic pipes. And it's also sold in aquarium places and gardening places for getting rid of algae and stuff out of lakes. They sell it in 5-gallon buckets, so it's pretty cheap. Heck, to flush it down the dang toilet, this is a lot better use for it than flushing it down the toilet. So between copper sulphate and your zinc flashing and other stuff you can scrounge up around home, something you can make pretty quickly and easily to get power whenever you need it. If all your alkaline batteries are dead and you can't get any more because of disaster strike, as long as you have root killer, zinc flashing, you've got power. And even for grins and giggles, to show that you can make anything into a gravity battery, I'm going to make this parts tray into a gravity battery. Anything that can hold water can be turned into a battery. See ya!